Welcome to today's Explainer. Get ready because we are heading out on a massive scientific mystery tour that is going to challenge absolutely everything we thought we knew about planetary formation. You see, for a long time, we looked at our own solar system, rocky planets on the inside, gas giants on the outside, and we just figured the rest of the universe must follow that exact same blueprint. But out in the dark, astronomers have discovered a class of planets so bizarre, so extreme, that they literally forced us to rewrite the textbooks.
All right, let's just jump right in. I want you to imagine a reality, a whole entire world where a full year, flashes by in just 3.5 Earth days. Just think about that for a second. You'd literally be celebrating a birthday twice a week.
Now, here is the crazy part. This is not science fiction. That's the actual orbital period of a very real class of exoplanets. And honestly, when scientists first detected these signals, they flat out didn't believe it. A massive gas giant orbiting that close to its host star? It seemed completely physically impossible based on everything we knew about how planetary physics worked.
Section 1. Meet the hot Jupiters, the discovery anomaly.
So let's kick off this investigation with our first major cosmic mystery. We found these giant gas planets exactly where our old trusty solar system models said they absolutely should not exist. And to get why this was such a massive shock, we have to look at what these planets actually are. These are massive gas giants. We're talking anywhere from 0.36 to 11.8 times the mass of Jupiter. Any bigger, around 13.6 Jupiter masses, and they'd ignite nuclear fusion and become brown dwarfs. But here they are. These huge balls of gas whipping around their host stars in less than 10 days. It completely shattered the idea that gas giants only form out in the freezing, distant, dark reaches of a star system. Just to put this into perspective, look at this stark contrast between the cold, distant gas giant in our own solar system and these chaotic, boiling worlds. Our Jupiter? It takes 12 Earth years to complete a single orbit way out in the freezing outer solar system. But hot Jupiters? They do the whole trip in under 10 days, just getting absolutely bathed in scorching stellar radiation. It is a completely different planetary reality. Section 2. Osiris, a famous pioneer. HD 209458b. Okay, let's ground some of this abstract astrophysics by looking at a real protagonist, a famous hot Jupiter, formerly known as HD 29458b, but informally and way more awesomely nicknamed Osiris. Sitting 157 light-years away in the constellation Pegasus, Osiris racked up a massive number of planetary firsts. It was the first planet we ever caught transiting, meaning it passed directly in front of its star and created a detectable dip in starlight. Because of that dip, astronomers were actually able to observe hydrogen literally boiling off and escaping into space. It was the first time we detected oxygen and carbon in an exoplanet's atmosphere. And get this, it was even the first time we measured a planetary superstorm outside our own solar system. Section 3. The migration mystery. How did they get so close? So because gas giants are supposed to form way far away from their star, out past the frost line where ice and gas can actually clump together, scientists rely on three main schools of thought to explain this puzzle. The first is in situ formation, which basically means they somehow managed to form right where they are, though honestly, a lot of experts find that highly unlikely. The second is disk migration. This is where the planet forms far out, but then smoothly surfs inward on a disk of primordial gas. And the third? High eccentricity migration. This is where planets are violently thrown inward by gravitational scattering with other planets or companion stars, eventually settling into a tight circular orbit because of tidal friction. But you know what really deepens this migration mystery? It's their extreme loneliness. Unlike warm Jupiters, which often have neighboring planets, hot Jupiters are curiously isolated. Only 7 to 12% of them have nearby planetary companions. For a long time, this overwhelmingly pointed toward that violent, high-eccentricity migration. The idea was that as the hot Jupiter was violently thrown inward, its massive gravity just cleared out or completely destroyed literally any neighboring planets in its path. Section 4. The radius inflation problem. Inexplicably huge planets. This brings us to a really fascinating question. Why do these planets have such unusually low densities and inexplicably massive sizes? You see, when a gas giant is bombarded with that much heat, yeah, we expect it to expand a bit, but what astronomers actually found completely defied the math. I absolutely love this analogy from our sources because it perfectly captures the sheer absurdity of the data. They describe it as being like a 6-year-old boy puffed up to the size of his dad. Take Osiris, for example. It actually has less mass than our Jupiter, only about 69% of it, yet its volume is 2.5 times greater. It is incredibly bloated. So we really have to ask ourselves, how on earth can a gas giant expand to such immense proportions? Look at the exoplanet TRES 4b. It has a density of just 0.222 grams per cubic centimeter. That is basically the density of cork. If you had a bathtub big enough, TRES 4b would literally float. Now, thermal evolution models showed that stellar radiation alone wasn't nearly enough to keep these planets this inflated billions of years after they formed. Something else has to be heating them from the inside. And the leading theory points to this incredible mechanism known as ohmic dissipation, or shallow heating. Because the planet is sitting so close to the star, the intense stellar irradiation thermally ionizes alkali metals right in the upper atmosphere. Then, these crazy supersonic winds drag those charged ions through the planet's global magnetic field. This induces massive electrical currents that flow down into the planetary envelope, dissipating energy as heat. It is literally heating the planet from the outside in. Astonishingly, new thermal evolution models reveal that this shallow heating reduces the planet's interior cooling rate by 95 to 98%. By trapping the primordial heat of formation deep inside the planet and then constantly injecting electrical heat just below the surface, this model perfectly explains why these gas giants stay continuously inflated. Section 5. Extreme climates and weather. Life on a tidally locked world. To truly grasp the weirdness of these worlds, we have to talk about their atmospheric chaos. Because of the intense gravitational tidal forces from being so incredibly close to their host star, these planets are rotationally locked in place. This is called tidal locking, and what it means is that one hemisphere is eternally facing the host star, just endlessly boiling under the radiation, while the other hemisphere faces out into the dark void, frozen in perpetual darkness. There is no sunrise or sunset here. And this immense gap between the day side and night side creates a severe thermal gradient. Back on our friend Osiris, the day side sits right around 1500 Kelvin, while the night side drops all the way down to 970 Kelvin. That is a temperature difference of over 500 Kelvin across the planetary surface. And as we know, nature absolutely abhors an imbalance like that, so the planet's atmosphere tries furiously to correct it. These extreme thermal differences whip up super-rotating equatorial jets. These are supersonic winds that just howl around the planet's equator, alongside these incredibly exotic vortices and storms. These intense wind systems violently mix the atmosphere, desperately trying to transfer heat from that boiling day side to the eternal night. It creates a never-ending, blistering, planet-wide hurricane of vaporized metals and scorching gas. Just wild to think about. Section 6. The Big Picture. Rewriting the Cosmos. By now, it's clear that hot Jupiters are way more than just cosmic oddities. They are the ultimate stress test for our understanding of atmospheric physics, orbital dynamics, and planetary evolution. They showed us definitively that the universe is not obligated to copy the layout of our solar system. Just a few decades ago, we didn't even know these inflated, boiling, supersonic gas giants existed. They broke our models, they forced us to rethink migration and atmospheric physics, and they completely expanded our imaginations. So I want to leave you with this final provocative thought. As telescopes like James Webb peer deeper and deeper into the galaxy, we have to wonder, what other impossible, bizarre worlds are out there just waiting in the dark to completely upend our understanding of the cosmos once again? Thank you so much for exploring this explainer with me, and keep looking up.